So, long story short, took the AMC 12B yesterday, or today, technically you're probably watching it in the future, and didn't do so well. Probably the lowest score, the fewest questions I've answered over the course of the last, we'll say 10 years. Having said that, sometimes you can find a silver lining somewhere. I loved doing question number 8 and felt really proud of myself for that. So I'm going to talk through it here, just because I figured I'd do it one more time while my rice is cooking for dinner. So the question number 8 is a trigonometric question, so dealing with trig. The question says the product of the lengths of two congruent sides of an obtuse isosceles triangle is equal to the product of the base and twice the triangle's height to the base. So just right there's a whole bunch of stuff to unpack. We'll do that. But just to kind of wrap this up, what is the measure in degrees of the vertex angle of this triangle? So we're ultimately trying to find that obtuse angle in the triangle, but there's a whole bunch of stuff to get there. And as I said, I found this one fascinating, and since I wasn't able to get a whole lot of other questions, this is to rebuild my self-esteem right here. So to start with, let's translate this a little bit. So we have the lengths of two congruent sides of an obtuse isosceles triangle. So to kick this off, I'm going to just start there. I'm going to draw an obtuse isosceles triangle. So is that truly obtuse or isosceles or obtuse? Well, it's reasonable. We'll call it what it is. And we've got two congruent sides. I'm going to call them A. I've called them A both times that I've done this today. So from here, we've got some other information. So it's equal to the product of the base and twice the triangle's height. So we've got something about the base and something about the triangle's height. So we need to deal with that a little bit. So let's label them as well. I'm going to call this base B. So that entire base is B. I'm also going to call this height H. So we got those two. And then what it says in here in addition is it says that we've got the product of the lengths of the two congruent sides, they are consecutive, but they're congruent as well, of this obtuse triangle. So what that's telling us in pink is that the product of those two congruent sides, which is A times A, those are the two that are the same, is going to be equal to the product of the base times twice the triangle's height to the base. So basically what we've just come up with is this sort of clean equation. And I will keep it, I will note for you that, I'm not rushing to get this right. Obviously it took me a little while on the test because I had to come back to it. But there's a relationship we got. Got a nice clean relationship there. Now, of course, our angle, the question we're looking for, is we want to figure out the vertex angle of this triangle. So we're actually trying to find something that I don't have labeled here, but I'll label it in here, theta. So there's our setup. Now, in order to attack this, based on looking at the triangle, what I notice is we've got two sides and an opposite side, both sort of defined. We don't know the values of any of those, but we've got those defined. So that's telling me that where I want to begin my attack here is the law of cosines. So I'm thinking that just based on what's there, we'll be able to relate the three sides together with that angle. So what is the law of cosines? Well, we want to be opposite the angle theta, so I'm going to have b squared is equal to a squared plus a squared, or b squared. Technically it's these things. It's a little confusing with the variables. I named them. I apologize, but we'll go with it. So side squared plus side squared minus 2 side times the cosine of the included angle. So cleaning this up just a little bit, because I noticed it helped me when I did this the second time, we'll get b squared equals 2a squared minus 2a squared cosine of theta. And I'm going to go ahead and clean that up a little bit, because again, I'm not doing this to practice the authentic timing of this contest. I'm just trying to clean up some of these ingredients as best I can. So there is a nice relationship. Obviously we've connected B and A together, but not quite all the way there. So if we want to continue forward with this, before we can get there, we need to use this second equation. Except we really can't use that second equation until we connect A, B, and H all together in some other way. So let's use some other basic geometry up here. And I'll switch to a plum color. Looking in here, we do in fact have a right triangle. The right triangle that we also have, that's sort of hidden in there, is this one. The hypotenuse is A, the height is obviously H, and then down below we just bisected the base of this triangle, so this is going to be B over 2. And the Pythagorean Theorem says that H squared plus B over 2 squared is going to equal A squared. So you know what, I'm going to go ahead and pursue this. And again, I'm not cutting through any steps here. I'm trying to show it a little bit clearly so you can follow what we got. So there's my equation. I'm going to multiply everything in this equation by 4. So we'll get 4h squared plus b squared is equal to 4a squared. But then here's the thing. We've got a whole bunch of relations with a, h, and b. I'm going to go ahead and take this into account. we have a squared. I see a squared is 2bh. Why not go ahead and take advantage? So 4h squared plus b squared is going to be equal to 4 times 2bh. And at this point, hopefully you're okay if I just go ahead and make that 8bh. Just for the moment, we now have a bunch of pieces here. We have like another equation for us to start to work with. The hard part is bridging the gap between these two. So let me show you how I did this. And I'm proud of this because it's a technique that one of my favorite math YouTubers has used a whole bunch. So I'm going to start by doing sort of what jumped out at me here. And it jumped out at me after hiding for quite a little bit of time, but bear with me. I'm going to divide both sides by bh. Now when I do that, I'm going to end up with 4h squared over bh, which is going to be 4h over b. Then in the next one, I'm going to get b squared over bh, which is going to be plus b over h. So we have some reciprocal action going on there. On the right side, we just get 8. Woohoo. Now in here, this is the spot. This is the spot that SyberMath inspired. I'm going to use substitution. And I want to make a video and said that just because I'm such a big fan of SyberMath. But in order to do that, let me go pull this off to the side so we have a little bit more space here. So let's throw this over here. So what am I going to do? I'm going to define a new variable, and I'm going to let u be equal to, let me make sure I choose the correct version. Yep, that's what I thought. I'm going to choose b over h. So now what does that do? Well, looking at our equation, this is 4 times 1 over b over h plus b over h all equal to 8. So what's that going to look like? Well, if I make that substitution, I'm going to have 4 over u plus u equals 8. And now I can multiply this entire equation, on both sides of course, keep balance, by u. And when I do, I get 4 plus u squared plus 8, is equal to 8u. And if I move this around a little bit, I'm going to get a quadratic relation. U squared minus 8u plus 4 is equal to 0. Now I need to solve this for u because I'm trying to get some relation between b and h, and at least then we'll have this sort of ratio, and trust me, it will pay off. So if we want to solve this, I could complete the square. There's lots of different ways to do it. Quadratic formula. I'm going to go ahead and complete the square. We cut negative 8 in half. We get negative 4. Square it, we get 16. So we're going to have u squared minus 8u plus 16. And then we have to do plus 4 minus 16, which is going to be negative 12. And if we go ahead and complete the square here, I'm going to have to move this down in just a second. But let's do that really fast. So giving us a little bit more space here. So completing the square, moving some stuff around here. This is going to become u minus 4 squared, all equals 12. And when we solve that for u, we're going to get that u is equal to 4 plus or minus, and this is the square root of 12. That's going to be plus or minus 2 root 3. So technically this does give us two options here. U equals 4 plus 2 square root of 3, or u equals 4 minus 2 square root of 3. So let's take a look at each of those possibilities. But of course it's worth remembering, like, well, what are we doing with that thing? What is this value? Well, recall, we let u equal b over h. So therefore we have our two possibilities here. And I'm going to choose, I'll choose the second one. This is what I did when I took the test, so I'll do the same thing. So if u is equal to that, that's the same thing as saying b over h is equal to 4 minus 2 square root of 3. And at this point it's like, okay, well, what does that do? Well, let's go back up to our law of cosines statement. If you recall, we had this particular statement here. Oops, come on. That b squared is equal to 2a squared times 1 minus cosine of theta. But remember, we've already established that a squared is equal to 2bh. So let's make a quick substitution. If you don't like substitution, you're going to have a rough time in this video. So what do we have? We have b squared. That's going to be equal to 2 times 2bh. And then, of course, times 1 minus cosine of theta. And then from here, what I'm going to do is, following sort of the same pattern, is I'm going to divide both sides. You might see it already. I'm going to divide both sides by 4bh. Obviously, 2 times 2 gets us to 4. When I do, now look at our, well, let's look at the right side first. Let's just go. On the right side, we have 1 minus cosine of theta. Cool. On the left side, b squared over b is going to divide out one of those b's, and we're going to be left with 1/4 times b over h. And hey, look at that. Look at that, it's right there. So I'm going to go ahead and make that substitution. So we'll have 1/4 times 4 minus 2 square root of 3. I'll point out, by the way, I'll scoot this down a little bit, that that value is going to be equal to 1 minus root 3 over 2. And that's going to be equal to 1 minus the cosine of theta. Now, if I set these equal, you can tell pretty fast that cosine of theta is going to be equal to root 3 over 2. But there's a problem with this. This doesn't work because, of course, we need, if you'll recall, to have an obtuse angle. So we are looking for an obtuse angle, and that's not going to happen when we have cosine positive. ASTC says the second quadrant is going to be negative cosine. So what that means is that we chose wrong. We chose poorly. So unfortunately, that means that this was not the solution. We need to choose the positive one. Fortunately for us, we can make that really fast. We can make a quick switch. I'll make that a plus. This will become a plus as well, because that's all we're doing is changing the sign of that bit. When we do, we're going to get that cosine of theta is equal to negative root 3 over 2. And this is the fun part. Cosine is equal to negative root 3 over 2. Again, I'll glorify this whole thing, get the whole piece. Root 3, 2, 1. This is a 30-degree reference angle, and in quadrant 2, that means that theta is equal to 150 degrees. Now, technically, do I know my answer's correct? No. Have I checked to make sure my answer's correct? No. Do I feel pretty confident in it nonetheless, and do I feel like this was the one way today that I can actually be proud of myself, even though it was question 8 on the 25-question AMC in which I didn't answer that many questions correct? Yes. Yes, I do. I am proud of this answer. And I'm going to post this. So there you go. There is my solution, my approach, using the law of cosines, the Pythagorean theorem, as well as a little bit of clever SyberMath-inspired substitution. And I got my answer of theta equals 150 degrees. Do I have the questions handy so I can even tell you for sure what that value or what answer choice that is? Yes, I do. I believe it's answer choice D. But beside the point, we got our answer, and there it is. Thanks for watching. Have a great day. Hopefully at least better than mine.